I'm Leonard Taylor. I'm the University of Maryland Medical Center Vice President for Facilities, and I'm the project executive for the Trauma Emergency Medicine and Critical Care Expansion Project. This is desperately needed. The Trauma Center, which is a key resource for trauma for this whole Maryland region, was built in the late 1980s with a plan to have a capacity of about 3,500 admissions a year. And we're doing close to 7,500 admissions annually, which means we're just busting at the seams. Similarly, our emergency department is overwhelmed daily, and we're always needing more intensive care beds. And this facility will provide vitally needed facilities in order to support that critical care medicine, which is so important to the citizens of Maryland and the surrounding communities. This building, which is planned to be 8 occupied stories, will include 64 new intensive care rooms. It will have 10 new operating rooms, which will result in a net increase of 5 rooms for our facility, because we have to use some of the older rooms, which are much smaller than the new ones, as support space. So we're renovating existing space to support 10 new ORs, and it will increase the emergency department rooms by over 18 rooms. It's going to include a second core lab. Laboratory is a very important part of supporting the care here. And while we have a major laboratory in our North Hospital, that's now almost a block away from this area of care. And this will provide us vitally needed redundancy in a critical support function, which helps from day to day. In the event that something breaks down, we always have a second one ready to go. And more broadly support some of our emergency management strategy, which all hospitals have to pay attention to based on the results of Katrina and other disasters, where if hospital doesn't have a plan to operate in extremis, it could really put the region at risk. It sort of falls in much way to the same story that I just said. Right now, because we only have one pad, it's almost impossible to service it, to do any major renovation to it without having to go to an alternate landing pad, which here regionally would mean someone would have to land in a parking lot, then we'd have to put the patient in an ambulance and drive them to our front door. So it sort of makes the purpose of the pad a little bit silly. With a second pad, we have an ability to close one pad while we fix the other. And the other reason we're excited about this new pad is a future generation of medical support helicopters may be substantially heavier than the ones that are flying now. And so we're anticipating we're building this pad to handle a higher lift, a higher weight, flying weight, so that we could support a future generation of air support ambulances. The medical center's got a pretty strong commitment to operating in a healthy and safe way. And when it gets to the physical environment, that means operating sustainably or in a green manner. And as you move that from operations to physical facilities, you want to build a facility that is safe to operate, uses low toxic materials, provides great opportunity for recycling, to use recycled materials, and foremost is low use in energy. So overall, generally, strategy towards a low carbon footprint. A way the building industry measures that these days is a independent certification process called LEED. LEED stands for Leadership in Energy Efficient Design. And it's a program sponsored by the U.S. Green Building Council. And applicants can apply to have their building certified that it meets a certain level of standards. Under the LEED certification system, there's 3 standards: silver, gold, and platinum. And we're aspiring to have this building certified at a gold level, which means it incorporates a great many sustainable features, would have outstanding indoor air quality, good environmental quality, built with low toxic materials, built with materials that could, to a large extent, could be purchased in the local region, operates with low energy, a whole list of very positive features. Lots of the features that would make a building sustainable, you wouldn't necessarily be able to tell until you probed a little bit. But there are a couple that will be obvious. We're going to use more automatic lighting control than we use now. So in areas that are not often, occupied sort of 24/7, there'll be occupancy sensors. So it'll turn the lights on when you walk in, and monitor for either movement in the room or something like that, and turn them off when it's clear that the room is empty. We'll be using, in a public area, you might be surprised to see a urinal that isn't connected to any water. So we're going to use waterless urinals in our public areas. The overall, and then if you get into the guts of the building and the way it's made, one of the things that we're pretty excited about is we're actually going to do some rainwater harvesting and use that rainwater, reuse that rainwater to help support our overall cooling system. This is like a triple play for us. It means in lieu of having to buy water to support our cooling towers, which help keep the cooling towers help cool the building by cooling the refrigerant that's actually circulated through the building. And in a conventional system, you take water out of the tap, you pass it through the cooling tower and run it out into the sewer system. In our case, we're going to capture rainwater and then reuse it in the cooling towers. Now, the reason that's a triple play is it means we won't be sending rainwater into the overburdened storm sewer system here in the city and then hence into the bay. So that's one win. We won't have to buy the water. That's a second win. We won't have to treat the water, which is a third win. As right now, water that comes out of the taps has a pH value that isn't very friendly to the mechanical equipment that we're using, so we have to add chemicals to it to change the pH so it's more friendly to the equipment, and then discharge that water into the sewer system. So by using that water in our cooling tower system, we do some pretty innovative stuff. Now that's sort of complicated engineering, but in many ways, some of the ways that one gets to real energy efficiency requires some creative engineering. And we've been fortunate to work, we're very fortunate. We have a brilliant engineer here that works for us in the hospital, and we're working with a very talented architecture and engineering company, Ballinger, out of Philadelphia, who's designing the building for us and helping us realize some of these plans. Well, anytime you spend $140 million or $160 million in a local area, there's lots of economic benefit. Construction employs lots of people. And it has to usually draw people from the local area. Part of our commitment in this project is that as we're shooting to 1/4 of the actual expenditure on construction would go to minority or disadvantaged firms in the region. And so through construction, we expect to employ lots of people, buy a lot of materials, and not only is there direct spending, but every man or woman who comes downtown to work on a construction site has to buy lunch somewhere, has to have steel toe boots, et cetera, et cetera. So there's a multiplier effect for every dollar we spend. And then long term, hospital's growing. We're going to need nurses and doctors and techs and clinical engineers and housekeepers to support the building. And our early analysis is we may add as many as 250 permanent jobs to support this expansion. To make things like this happen, there's lots of groundwork that has to be done, and we often call that enabling moves. So this began with, there was a building on that site that had to be knocked down and carted away. And in fact, we did that in a way that we could recycle as many materials as came out of that old brick building as we could, because that was part of our lead strategy, to recycle any construction spoils. We're moving in parts of in areas adjacent to the new construction, there's occupied space, and some of that will be converted from its present use. In one case, the full third floor of the shock trauma building has presently offices in it. That will become a new ICU as well. And so we're having to renovate other parts of the hospital into office space so we can clear that space for the new ICU. So there's often many sort of domino moves that we're involved with. Right now, if you are if you're in that corner of our hospital this week, you'll see a very interesting piece of equipment, a concrete pumping truck. Looks like a sort of strange, it looks like an elephant with an extremely long trunk. And we're building a series of connecting pathways from the Weinberg building to the trauma building on floors 3, 4, 5, and 6. And to get the concrete up there that people will end up walking on, you have to pump it up. And so we've got a concrete pumper truck out there today, which is kind of, I mean, if you're like me and I get captivated by watching construction equipment. I have since I was 4-year-old. You could just sit there and watch this stuff all day long. I think what I want people to know is we're terribly excited about this. Foremost about the medicine and care that will go on in the facility, and that we're creating a wrapper or a frame for that. One of the things I didn't mention, actually, when we're done, and one of the things two things we're very proud of that this will include. One is a brand new waiting area for our shock trauma visitors and those families that are waiting to hear about the outcome of their loved one. Right now, unfortunately, those families sort of wait at the corner of First and Main on our first floor, and we're building them a really appropriate area that will be a place for people to get together as a family, to consult with the caregivers in an appropriate environment. We're very excited about that. We're also, as part of our broader mission as a teaching hospital, which of course distinguishes the University of Maryland Medical Center from other hospitals in the state, is we're building a major simulation center where we can help train doctors and nurses before they actually have to touch real patients, and using the latest in technology and the latest in our knowledge about how do you treat trauma victims. And that will happen here right next door, in fact, right one floor below where the trauma teams are going to work every day.